it is a bubble deck. Okay, I hope that you have heard about this bubble deck before. Okay, the bubble deck system is actually a biaxial holodeck. Okay, it's a commonly named as a biaxial holodeck in our European standards. Okay, it's one of the innovative GBI certified and IBS components approved by the CIDB Malaysia. So this is our first project. Okay, as you can see here, we tried to find a solution for this hotel before because the area is too constrained. It's located near a stretch along this Jalan Tunku Abdul Rahman. And there's a risk also because it's right next to the KL monorail track. So towards the end of the process, okay, the client feedbacks is very positively because of this. Their labor cost is saving up until 40%, and the construction time also have been reduced to 40%. Okay, and even the floor cycles also increased from 2.5 to 4 floors per month. So for that particular time, it was a record for them. Okay. And also the site concrete also reduced from half for the actual floor. So the great saving in rental of tower crane and the rubbish disposal is enlarged. Okay. So in terms of overall, obviously it cut costs, the construction cost at least by 20 to 30%. So this is our first experience using a bubble deck in Malaysia. Okay, then this video actually is a bit more on a bubble decks in Malaysia, how they start, how they're doing the works in Malaysia. So hopefully, sorry, I play this video first, then you can go through after this.
The bubble deck system is a hollow flat slab that spans in 2 directions, in which recycled plastic balls are incorporated to laminate concrete in the middle of the slab, not contributing to the structure performance. Operating risk is minimized because bubble deck is manufactured off-site in a controlled environment. It reduces the need of vehicle trips and crane lift. This combines with a simple installation, minimizes operation risk and lower health and safety risk on the job site. The bubble deck slab system consists of semi-precast element with a 60 mm permanent concrete shuttering, which is placed together on site to form a strong and stable concrete frame. Loose reinforcements are inserted across the joints between the elements for added strength. The remaining concrete is cast in situ to form a finished slab. Following the placing and curing of the in situ concrete, the joints between the elements structurally disappeared. The whole slab becomes a monolithic slab standing in 2 directions on the reinforced concrete columns. Bubble deck innovative building method produces a wide range of cost and construction benefits. By reducing floor thickness and foundation, bubble deck can save up to 10% construction cost. Floor cycle up to 40% faster than traditional construction method. Greater span up to 40 times the slab thickness is achievable in both directions. Bubble deck offers design flexibility, adopts irregular and curved layouts, can deliver up to 10 times the slab thickness. Beams are not necessary, producing a reduced structural depth. Bubble deck is environmentally green and sustainable due to reduced carbon emissions arising from construction. Bubble deck contributes up to maximum 50 points IBS scores and 5 GBI credits. Many projects around Malaysia have chosen the bubble deck innovative technology. Bubble deck, a low-risk IBS certified floor slab system to build large and complex building. Bubble deck, building more with less.
Okay, this is our inventor. Okay, actually it's from Denmark. Professor Jagan has been around in this industry for at least 45 years, and he's one of the lecturer in University of Denmark. Okay, right now his son, Mr. Bruning himself, is one of the active one to work around throughout the world just to introduce these bubble deck systems to the markets. Okay, this is bubble deck throughout the world. As you can see, we started off in UK, Ireland, Netherlands. Most of them is Europe countries. And in Malaysia, we started in 2012. Okay, so it's been then more than 8 years right now, and we are covering up Malaysia and Singapore as well. But the most active teams, bubble deck teams in the world right now, has been in Australia and in New Zealand. Okay, there's one part of the Australia is in Perth actually. So most of the buildings are using a bubble deck So I'll explain and give you some examples of their towers after this. Okay, this is one case study for our bubble deck. Okay, the interesting part of this building is that because there's one particular scenario. Okay, originally the design for this building is only for 33 floors. Okay, and then after using bubble deck, we can introduce another 2 floors within the same heights, and even the erection cycle for per story was reduced from half from the actual erection cycle, and the number of crane also have been reduced by 50%. So in the end of the day, most of the saving is more or less on the material itself, and the speed of construction is increased also. Okay, the principal concept of bubble deck system is we radically improve the building design itself. Okay, the labor efficiency and the construction speeds. So we will try to increase these 3 items more into our system. Basically, bubble deck is a mesh between top and bottom mesh. Okay, and we call it. We have 2 parts actually. One is on-site pouring, and the first part is the half-length precast panels. So it consists of balls, mesh, and the bottom parts of the precast component. So it can facilitate up to 50% of longer conventional spans if we apply this bubble deck into our system. Basically, the ball is reducing the weight of the slab itself, okay, at least by 30%. Okay, for the flexibility of the shape itself, so we can design it in all shape that have been required. Is it either it's round or circular shapes or triangular? It depends on the design. So it's a flexible system in terms of design. Okay, we have some certifications also. Okay, for the CIDB IBS, we can score up until 50%, 50 IBS points. Okay, this 50% maximum is depends on the support system that we have. Okay, we can give up until 50. And we have also have a certification from CREAMS and CIRIM. Okay, basically it's a firefighting requirement. Ours is 2 hours fighting, and it is according to the British standard as well. And we can give you up to 5 GBI points as well in terms of the green building. So we have been put into a green page and it's certified by them. This is our manufacturing arm. Okay, we have one arm in we have one factory in Rasa. Okay, it's under BDC Concrete, and it is also as ISO certified. Okay. Okay, this session is more on towards how we manufacture it from the factory and we send it to the site. Okay, as you can see, there's a panel 7 stack in our factory, right? Okay, this one is actually ready to deliver. So it's actually once we cast it, the bottom part, we need to cure it. The curing process should be at least 7 days from the day we cast it. Okay, once the panel is ready, and then we stack up into the lorry and send it to the delivery site. Okay, but before that, we must make sure that our support system, which is the scaffolding itself, must be ready. Okay, everything must be according towards our requirement, and basically we delivered in just in time process. Okay, this is the delivery at the site and the lifting process toward the floor, the actual floor. After this, I'll give you the video just to show you up the actual process. So this is the time to adjust the panel into the predetermined position. As you can see, all of our support, the propping must be perpendicular to the runners to the panel itself. So this is the video I mentioned before. Okay. This is the panel. As you can see, there's a panel that we need to send to the delivery floor. Okay. And we need only 1, 2, 3, 4 levels, 5 lah. Okay. Just to make sure that this panel is fitted into the exact situation that on the floor requirement. Basically, we just need maybe around 3 to 5 minutes per panel to install it into the site. Okay, make sure the ball is in line, and then done. Okay, so it's easy to install actually. Okay, this is on the side of our panel. Okay, as you can see, as compared to conventional, we have at least 50% less than the conventional propping system. So we basically save into the propping itself. We can save up until 50%. Okay, but it depends on your span and your floor area as well. So once we install all the panels on site, we need to install our pre-cut or our splicing bar. Okay, this is to make sure that the top portion is monolithic throughout the floor. Okay, only the bottom portions is only the precast, but we need to stitch it back and make sure it is a monolithic structure throughout the floor. And this is the column capital reinforcement. Okay, I would say that our design is more on a flat slab system. So it's a not conventional system as well. So we need to do the column capital reinforcement within the column area. But we remove all the balls within this section. Okay. The shuttering that we need only at the edge only. So, but sometimes we can create a precast shuttering system for especially in Singapore, because most of them are more on the precast component. So sometimes we can design it in that way. Okay. As you can see here is installation of the M&E. So we can fit in all the M&E conduits within the slabs. So it is easily done. Okay, previously we have worked more than 20 towers that they're using bubble deck, so there's no problem installing on this type of M&E. And before we pour the concrete, we need to do a prepare and inspect the rebar installation in a proper manner. Okay, we have our own supervisor, and we have our own engineers. Checking the things before we cast all the floors is considered as crucial, because all the details must be precisely installed into the slab itself. And this is the concreting process. It's similar to what we have in the conventional system. We can use any type of concrete grade, either it's high strength or any type of markets right now. And the leveling process, okay, for this slab, every drop that we need, we just remove the balls and make it drop onto the floor. So it is simple and it's easier also. Okay, this is an optional. Okay, for the back propping, for high-rise building, we need at least 3 floors below to prop the actual floor that we cast. Okay, this is crucial to support the self weight of the slab itself before we remove all the support. Okay, basically we will advise on this manner as well. And then this is the completed one. Okay, as you can see, there's no column drop here, so it's a clean soffit surface, and easily we can go up until 14 meter span. Okay, for this kind of system. For optional, basically for them, basically they will just seal up the bottom part with a skim coat and paint it. Just paint it is okay. But sometimes, most of the case, they just bare finish it. Okay, just leave it there and just expose the groove like I think architects more or less. I can show you the sample after this. Okay, this is the floor cycle. Okay, basically for a conventional system, per floor with this kind of area, also 800 square meters, easily it can be done by 7 to 10 days per floor. But ours, we can reduce it up to 6.5 days per floor. So the speed of construction itself is increased. So basically, this is the most convenient case for the client to adopt our bubble deck system. So the advantages of using our products is based on 3 factors. Okay, by architectural advantages, of course, your headroom is increased. Okay, as you can see on the left, there's a conventional system with beams and slab, with drops and drop heads as well. So your headroom is more clearer and more higher. Okay, as compared to the conventional system. This is the example. Okay, within the same height, 3.4 meter floor to floor height, we can increase up until 300 mm. So we can allow more working space for your M&E, conduits, ductings, everything running into the soffit or slab. So it easily to install the M&E parts. Okay, and it can increase your headroom as well. As you can see, sorry, on the left with beams, on the right without beams. So it's more clearer, more bright into your room as well, and your windows positioning is more higher, so it's more suitable for rooms exposure within, for the hotel actually. And for the ducting as well, more or less it's straightforward installation without any cutting down through the beams, or sometimes it's just protruded through the beams, so it's easily to install actually. As you can see, right and left, there's a lot of differences. Okay. Okay, the specialty of the bubble deck also is more on the cantilever requirement. Okay, we can go further up 30% as compared to the conventional one, without any beams, without any drops, or we can go 10 times the thickness of the slab itself. So basically, for ours, we can easily go up to 5-meter cantilever without any beam to support it. And because of this very large span, your lightning is very bright, especially for the car park area. Okay, because with beams and here and there, of course, you need a lot of lighting to be installed into your car park area. So this giving you a more spacious area. Okay, and the free choice of shape. Okay, of course, I think architect more prominent into the free choice of shapes. They want to design in all aspect of round or maybe circular. So we can design into whatever type of structure that you need. Okay. And for the engineering advantages, okay, of course, it is a beamless design. Okay. So most of our case, we reduce all the beams and we just replace it with a flat slab. Okay. So our slab also is lighter. Of course, it can bring a less foundation, a less deflection for long span. So this criteria basically is more lesser than what we have in the standards. Okay. And of course, there's no water condensation and seepage, because bubble deck system is actually a seamless monolithic floor slab system. This is our design criteria. As you can see, it's been incorporated in Eurocode, I think in 2006, 2007. Okay. So the basic geometry is something like this. Okay. We can use any type of concrete grade, but the norm is 35, and the ball itself is a recycled plastic hollow balls, and it is locally produced by one of the manufacturers in Malaysia. Okay, and within the thickness we have 5 sizes. Okay, 230 and up until 450. But the usage depends on your span, depends on your cantilever requirement, because sometimes they need a 4.5-meter requirement. So we can propose to them immediately what type of slab thickness that we can use. Okay, we have 5 sizes. And of course, for the contractor advantages, is that tailor-made. So the assurance of the quality, and less weather dependent is there, because our factory is shaded throughout all the floors. So we can control the QC in a good manner. Okay, and there's no beam casting on site. Of course, it can reduce cost and less material and rubbish handling and lifting on site, especially your concrete, your steel bar, your former scaffoldings, and it can simplify faster M&E works. Okay, actually there's no restriction for M&E fittings. You can fit most of your M&E parts into our soffit floor. As you can see, we can hold up a big fan here. We can hold up firefighting easily, and your ducting and everything. So in a good manner. Okay, the installation is easy and faster. Okay, and of course, most important thing right now is less skill labor dependent. Okay. As you can see right now, we are dealing with COVID-19 issues. So of course, most of our contractors locally, basically they have an issue with labor. So this can help actually. Okay, actually not only our product, actually most of the precast panels or precast component that we have on the market right now is the best solution right now to use. So I believe Malaysia government right now is into they're trying to get their parts, okay, to introduce this IBS system into our markets. Is it a good time actually? And less burden on your rubbish disposal. As you can see, as compared to conventional system, our bubble deck is more clean. So the rubbish is controllable, can be controlled easily without any ado. Okay, so this conventional system and bubble deck, the differences also is in term of our supporting system. Okay, as conventional, there's a lot of scaffolding that we needed, and for bubble deck, we only need maybe less than 50% from what the conventional system have. Okay, and lastly, for the developer, of course, they are saving in terms of financial. Okay, reduce the structure weight, of course, can saving in terms of their foundation as well by at least 30%, and can bring a faster ROI, return on investment, for them also, because the faster the building is being built, of course, the faster they can get their return. Okay, and in terms of saving in financial interest from the bank, most because sometimes contractor have made some facilities towards the bank, so of course they can reduce the interest by reducing the months that have been achieved, saving from they using a bubble deck. So of course, in flexibility in building design, of course, it can bring a cheaper on-site changes. Okay. From environment side, of course, it use a less concrete. Okay, every 1 kilo of recycled plastic board can save 100 kilo of concrete. Less carbon dioxide. Okay, saving up to 40 kilo of CO2 per meter square. Okay, minimum formworks required, because our panel is considered as a permanent formworks. So this additional formworks is only for the edge side only. So it can reduce a lot of usage of trees. Okay, and the less foundation. For example, okay, let's say the foundation itself is we design it using a bubble deck. Most of the case is the lower loading requirement for the building itself is reduced. Okay, of course the excavation for the basement is lesser. Okay, so most worst come to us, the design throughout the process, it can be cheaper as well. And of course, there's better sound insulation and better thermal insulation. Okay, for this last section, I will explain more on the project that we have done in Malaysia and throughout the world. Okay, for project in Malaysia, we did a lot of high-rise and some low-rise also. But this example is more on the prominent project that we have in Malaysia. Okay, this is a project that we joint venture with Setia Federal Hill. Okay, it's under Setia development. Okay, Setia is considered one of the prominent developer in Malaysia right now. Okay, this is considered, okay, this achievement actually we did it a few years ago, and it has been certified as the highest IBS core project in Malaysia. It's a 93.95 at that particular time. I think right now we have another one, 95.6. There's another developer. Okay, so all the system itself is a precast, including the shear wall, beams, columns, slab is by bubble decks, and even the wall, some is by using our system as well. So it's the combination between these few precast components gave an excellent aesthetic, okay, towards this building. Okay, and the span for this building also is quite high. It's around 10.79 meters. So actually we reduce a lot of support, okay, by using our bubble decks. And the second one is the Tropicana Garden. As you can see, this is the tower that we built. Okay, it's located in Kota Damansara. Right? It's a 25 floors tower, and the condition of the site also is very tight. Okay, we have a traffic problem issue as well, and the site issue is very constrained. Okay, so we have a very limited space to do our jobs. So that's why they're trying to get our help, and that is the time that bubble deck will be introduced into this project. Okay. As you can see the differences. Okay. for this project, we started with actually a continuity with, from the previous floor. Okay, this is their level 7 floor. Okay, they're using a PT slab. The problem is that they try to finish the per floor construction period within 2 weeks, but it extended out up until 1 month per floor. So there have been delay quite in serious times. So they're asking our help how to improve their construction times and whatnot. So we proposed to them using a bubble deck. So after we using bubble deck, it's improved them a lot in terms of timing periods. Okay. Before that, they have been delayed up until 2 months, and after they are using our products, they are ahead of their projects by within 1 month. So it's an advantage to them to use our product. And the differences is, of course, there's a lot of beams at the lower floor. As compared to us, it's a clean soffit, so you can do a lot of things beneath the soffit. This is another one. Okay, I think this is the most highest tower that we built in Malaysia. It's up until 26th floor, I think 26 to 27. Okay, and this is located in Bandar Tasik Selatan. I think once you reach, I think you're familiar with, if you're familiar with TBS, it's just side the building only. Okay. This building is a curve-shaped building, and we did it. It was completed in last year, but right now they're doing the facade. Okay, once you come to Kuala Lumpur, maybe you can see the building by itself. And this is Menara Kuala Chu. Okay, the location just in front in Pavilion Shopping Mall. This is belong to Melton Berhad. This one also we did help them a lot in terms of the construction period. Okay, they've been delayed quite sometimes for the building, so they asked us for our help to introduce this bubble deck. And the span is 40 meters. I think this is the most longest span that we did for bubble deck in Malaysia. It's one span and considered as the longest span. And most of our structure we built in Malaysia is more or less the car park structure. Okay, this one is for safety alarm. As you can see, the activities from the propping system and the launching, and we install the panels on the floors and casting. So there's a 1 cycle period of floors. Okay. Okay, this is an example of one of the car park that we did. Okay, the architect prefer to make it as a bare finish, so they didn't paint it. Okay. And this is one example of our car park as well in the BKL. This one they paint it. Okay, it's a clean soffit surface for them. Okay. We did also for the food factory. This one belongs to Kawan Food, one of the biggest supplier for roti canai in the world right now. And the floor area is quite big and massive. Okay. And the floor span is around 10 meters span, and with a loading of 10 kilonewton per meter square. Okay. This one is for their storage purpose. So actually, bubble deck can be done in all type of structures and area. Okay. And we did also for the police, for PDRM. Okay, this one is HQ for contingent in Kanga Police. We have done their job for the office area and the quarters area. This project also we help them in terms of the finish project. Okay, they have managed to finish up their project 3 months earlier than from the proposed finished project. So it is a good project example for us. And we did a podium as well. This one is for car park, and this is our own factory in Rasala. Okay, as you can see, there's a long cantilever here. Actually, on our previous car park, we have also a long cantilever we did for them, so we can create a longer cantilever requirement as compared to the conventional one. And of course, we can use our product also to build a bungalow. Okay, we have done quite a few bungalows here in Kuala Lumpur. Okay, most of them they're finished lah. Okay, this is belong to one of uh, one of the vegetable seller in Kuala Lumpur, supplier actually, big supplier for the Kuala Lumpur area. So this is a building we did for the slabs and the rooftop lah. Okay, and this is the PAM Center lah, Persatuan Arkitek Malaysia. Okay, this one completed 3 years ago, 3 to 4 years ago. Okay, as you can see, it create a good, a great, yeah. Okay, sorry. Maybe you can, when you reach Kuala Lumpur, maybe you can come to the PAM Center and learn something from there. Okay, we have a lot of example in here in Kuala Lumpur, so you can reach me out here if you want to go. Okay. And this is also one of the houses that we built in Kuala Lumpur. We call it a planter box house. This one is a very unique house actually, and if you can search it on Facebook, there's a lot of videos regarding this house. And of course, throughout the world, in Italy, we have 44 floors tower. Okay, this, I think this is the tallest building that have been used for bubble deck before. Okay, and Perth. Okay, actually, this is one of the project that we did for Perth in Australia. Actually, they have more than 5 buildings using a bubble deck before. So this is one of them. Okay. The curve in Holland, the City Hall in Denmark. As you can see also, there's a long cantilever here, okay, this portion. So it can be used as a spacious cantilever, okay. It is a special one actually for this building. And this is in Canada. This one is in Netherlands, okay. And of course, this one is in Norway, okay. So I think this is all from me. If you have any question, maybe you can ask me after this. I can answer it. I try my best to answer it. Okay.
Yeah, so, there's a question from the student.
Okay.
Okay. Will the student want to ask, through your mic? Ahmad?
Abad.
Yeah, so we have some, two-way conversation.
Oh, you will. Okay. I try to remove.
Yeah, there are actually some question at the chat box. Okay. From student. In fact, I'm aware that there are some master students in the group too. So yeah, we actually broadcast it mainly from the 3rd year, but we also open it to the master students. Seems like some of them, they are joining us.
Yeah, okay. Yeah. I see a lot of questions here.
Yeah. Okay. Yeah, a lot of questions.
I try to answer it one by one. Okay.
Yeah.
Right. Okay. First question is from Ahmad Kamil. Okay. Does that mean bubble deck system does not require beam? Okay. Actually, our system is a flat slab system. Okay. In design terms, we have few types of structure that we did. Okay. One is conventional beam and slab. Another one is flat slab. Another one is PT. Okay. PT is post-tensioning slab. Okay, so for this kind of flat slab, basically we does not any require beam, except for the ramp area. Maybe there's some staircase area. So most of the case we try to reduce all the beams inside our slab. Okay, so it is one of the systems, so that not require any beam at all. Okay, I think that's answer your question. Okay, and for Natasha Yazid, what's the longest span for cantilevered bubble? Okay, I think I answered it during my presentation. It's around 5 meter span, but it depends on the sizes and the loading applied on top. Okay, but for us, we can go up until 5 meter cantilever. 17 meter Amirul Irfan. Okay, Amirul Irfan, 17 meter is applied for our thickest slab applied. It's under 450 mm. We can go up until 70 meters, but it must be in continuous way. Okay, it's not simply supported. Okay, so 70 meter we can achieve it based on our actual project in overseas. But right now the most longest span that we have only 40 meters in Malaysia, but we can achieve up until 70 meters, no problem. Okay, from Miss Chia Wei Lui. Okay, Is this system suitable for green roof design? Will there be any constraint? Actually, our system also can be used as a flat roof design. Okay, of course, it can be a green roof design because we are GBI certified. We are more on saving on environments and all that. So you can see my presentation before. It's more or less considered as a green structures. So any constraint for roof also, you need to do some waterproofing, okay, as well as a conventional one. So when you want to go in terms of leakage one, I think it doesn't have any issue on that as long we have a proper protection on top. Okay, as considered as a normal design as well. Okay, we can consider ourselves as a green roof as well. Okay. From Sarah, Miss Sarah, okay, you asked for the weight of the board. Is it from plastic? It's actually a recycled plastic. Okay. The weight is, I think, I'm not sure about the weight, how much the weight. It depends on the size. Okay. It's very light. Okay. So it's from recycled plastic and it's locally made. Okay. We didn't import it from outside. It's locally made here in Malaysia. So it's a recycled plastic. We can use a recycled plastic for all types of our structure. So, okay, how long does it last? Is there bubble in the floor? Actually, the bubble itself, for us, is just to reduce the weight of the slab. Okay. As a design criteria for slab, the strength at the middle of the slab, there's no strength at all, actually. Okay. Once we remove the area inside at the center part of the slab, the strength is more on top and bottom. So once the balls is deteriorate or maybe suddenly hilang for throughout the years, okay, it doesn't affect our slab at all. Okay. Sorry. And how does it long? It depends up into the design consideration. Okay. Actually, the bubble itself is not important. It's just to create a void inside the slab, just to reduce the weight. Okay. And another question from Sarah, is bubble decking widely used in Malaysia by other company? Okay, what do you think system will replace other system? Okay, right now we are considering ourselves quite positively in the markets, and I think people, I think the developer or maybe the consultants, architects have been recognized us in the markets. Okay, since then I think we have done more than 50 structures in hand in Malaysia. From 2012. So I believe in Malaysia we are being accepted well. Okay, and we can't say that our system can replace the other system in the future. We can say that our system can merge easily with the current system. Okay, that easily apply in Malaysia. Okay, we can work together with any type of structure. It's not a problem for us. Okay. And then from Sarah again, okay, is there any disadvantages of using? Of course, there's a lot of some sort advantages, disadvantages, but it depends on the situation. Okay, sometimes it depends a lot of the contractor side. They need to do the job properly. They need to install our product properly. So when the things properly done, properly installed, so basically the advantages of this bubble deck, of course, we can contribute more to the markets, but these advantages may come maybe during the installation. There's some minor crack that they need to hack it out, so it delay the works. So this kind of disadvantages we can't treat it as but we can solve it immediately. No problem. The problem faced basically during the installation, okay, the learning curve of the process. Maybe some of the contractor that may be familiar with the conventional one rather than the precast. So right now the precast is more or less acceptable, especially in urban area. Okay, they need a lot of this kind of structure to help them to increase productivity. Okay, into our constructions area. So how the ball actually works in supporting load without any beam. Okay, as I explained earlier, the ball is actually just to create a void. Okay, the structures, the supporting system must be created by the rebar and everything inside. So the top portion and the bottom portion must be designed accordingly to the standard. So the loading factors, the supporting factors is based on the rebar only, not from the void. Okay, void is only to consider to reduce the weight of the slab itself. Okay, this one I think you can try to read it out into our Eurocode standard. There's a lot of Q&A in this section. Okay. Okay, from Miss Turaya, okay, it's Miss, right? Okay. This technology is tailored for concrete structure only, cannot adapted to steel construction. Yes, we did a few, we call it a hybrid system actually. For some of the column support, they're using a steel, H steel some column support. So we can merge together with this kind of details. Not a problem for us. We did quite a lot of activities with them before. It can be tailored to any type of construction. Okay, I would say. Okay, how? Okay, from Miss from Eddie. Okay, how is the performance in terms of noise created by occupant in building? Okay, as you can see, in terms of noise, actually we did quite a few studies, okay, in terms of noise cancellation and the vibration issues into our slab. I would say that our noise cancellation can be increased because there's a void inside. Of course, there's a study being said that the noise can be reduced throughout the void inside the slab. So it being tested before. So I would say that our slab can reduce the noise from below or from the upper side of the building. Okay. So it can be we can use our slab efficiently if some hotel developer want to use our product. So it can help them a lot. No problem. Does this come with warranty? Yes, yes. We have our own warranty. We have a supply warranty. We have design warranty as well. So the design warranty depends on how long the building itself being designed, whether it's 99 years or 60 years or 120 years. It depends on the standard that we apply. Okay. For our supplier side, we make sure the guarantee is within this design period as well. But it depends on the constructability and the consultant approval as well. So we have our warranty as well. No problem. So, is there any question else that I
Yes,
can?
from me.
Oh yeah, from you. Finally.
Okay. Yeah. Thank you so much for the questions, dear student.
Okay.
Yeah.
So,
Okay.
it's a good question actually.
Yeah. It's a good question. I know some of the questions are repeating, but it's good because
Mm,
this is our very first times being exposed to this. So
mm.
they might be a bit confused. So they ask things
Yeah.
repeatedly just to confirm on that, which is good.
Okay, understood.
Okay,
Understood.
I personally interested with some question regarding practice side because I actually still practicing.
Okay.
How about the CMS scope of work in comparison
Okay.
with your prior project? Normally they will have the CMS engineer on board. So,
Yeah.
so how they deal with that, the scope of work between the CMS engineer for the buildings and your scope?
Okay, actually, it depends on which area that we entered before. Okay, sometimes we have been asked from the contractor to supply an alternative design. Okay, then we must meet the actual CNS for this project. Okay, basically CNS will check our design as well according to the standard requirement. Okay, either British standards or Euro codes. So it depends on the requirement by them. Then after we get some approval from them, and we have to get a back-to-back approval, okay, because we have our own professional engineers they certified for the drawings, for the design reports. So we have our own PE, okay, and the back-to-back approval with back-to-back approval with the CNS main PE. So in terms of working scope, there are the consultant more concerned on their support system, like especially the columns, the shear walls, everything. But they need to know our distribution of loads from our slab, okay, towards the buildings, especially if the building's more on the frames analysis. So we need to merge with their analysis, and we can work out together with them. So in terms of scopes, ours is more concentrated more on the slab, and theirs is more concerned on the overall structures plus our system. So they need to know how our system works together with the system. So part and parcel, the process is more or less we need to merge with the system together. Then it can be worked out easily.
Okay, yeah,
Mm.
okay. So what about through your presentation, you mentioned that one of the highest building you have adopt the bubble deck was about 26 story. Was that a high
Mm.
control in this using the bubble deck? Could
No,
we?
but
Mm,
basically we try to maintain the height control that the approved. Basically, we have an approved height, okay, from the previous from the original architects, because they are the main the body that govern this area. So we try to maintain whatever the height that we have, lah. But
Oh,
sometimes,
I mean the total floor. Say, could I actually still use bubble deck for 100-story tall buildings?
okay,
Yeah.
in terms of that particular case, we never done more than 45 floors before. Okay,
What was the
but it can
issue?
the reason why, because of some seismic issue. Okay, seismic issue, because our bubble deck is more on they are more prone on the vibration. Okay, the vibration side. So the wind factors we need to analyze properly. But it can be done with merging together within few systems. Okay, that's the conventional plus our system. So we can work out together with the conventional system. Either they introduce more frames, more shear wall at the core, center core there. So plus and minus we can work up, but we haven't given such an activities for this time being. But it can be done more than 45 plus. But we need to merge with the existing system that we have.
Okay. Transportation wise wouldn't be a problem, right? Because
No.
okay. Because
For the time being, for the time being, we have enough support teams.
Yeah. The thing is, because through the presentation, I saw that it is actually a precast with the bubble decks, and then if we are doing a slightly higher floor, the procedure is about the same too.
Yeah, procedure is the same too. They need a higher tower crane, and they need a higher capacity tower crane to lift up our panels into the located floors. It's the same criteria. Not a problem for us.
Do you allow hacking on the floor?
Yeah, we can allow hacking, but with some method statement that we need to apply. Okay. It's a norm as compared to conventional. Also, it is a normal kind of works also.
Yeah, so which means that if we are using these for apartments, and some hacking might be done by the tenant, is still allowed.
It's still allowed, but the consultant need to get some sort of advice from us before we proceed.
Okay. What I mean is the end purchaser. Say that I do not know whether apartment has used these types of bubble deck system before.
We have one project currently.
Using apartment.
Yes, using apartment.
Okay, it's about apartment. What I mean is, what about end user that So sometimes end user, once they move in, they might start hacking things. Will that be an issue?
Basically, in apartment, there's seldom.
Yeah, seldom.
Seldom they try to hack the slab themselves.
Yeah,
unless they bought the 2 units top and floor, they want to hack it out and put a stairs in between. So that's the seldom case that I heard.
Case, yeah. But
most of them they try to hack the walls and everything. But yes, we can consider to hack it out. No problem. But only that we need to determine where is the area that need to hack, and we need to check again their design. But easily it can be done, no problem. But with some protection also during the reconstruction. So it's okay.
Okay. So after you have deal with so many cases, building site in Malaysia, generally what are the misunderstanding of the designer or the architect or the client toward bubble decks?
The misunderstanding,
they think is or the things that pull them away from using bubble deck. Is it the cost?
Most basically the cost. Okay, I would say most basically the cost, and the second one also, there's some misunderstanding because ours is less beams, less support. So sometimes they're asking can we do something like this, 10 meters, 20 meters, we can go further. No, there must be some limitation into our products. So that's why they need to understand the concept of flat slab and the concept of conventional beam and slab. So sometimes they get confused within these two areas, especially on the architect side. So they need to do some study on that. But I would say that it's a common problem, but it can be solved. But only that the main part.
The architect insists of using beam or what?
Yeah. There's some kind of once or most of the students said, based on the question that have been asked me for quite some time also, why no beams? Why no beams? So there's a difference concept between flat slab and so flat slab is totally dependent on your column support. So every loads transfer directly to the columns. So beam and slab is they need to transfer the loads to the beam first, then the beam transfer the load to the column. So it's a different type of
It's a different
ways.
type. Construction
So,
system.
so
Okay. There is one question from Eddie again. If there is an
mhm.
alterations on the building, how do you propose it to be done? I think you
Okay.
answered that.
Yeah. I answered it during the
Yeah.
with you.
Yeah.
So
So
I would say that the alteration can be done, no problem. Only that the area they need to hack, they need to be get some advice from us also, lah. Okay. But some of it, if the opening is too small, maybe it's around 200 mm or 300 mm below. So the center part is the safest part. Okay. From the concept of the flat slab, okay, the center part of the slab is the safest part. Okay. Anything near to the support is dangerous. So if you want to hack near to the support, we need to get our some approval first, or at least from the CNS first. Then we try to reduce the effect of the failure, lah. Because so the treatment is similar to what we did for the conventional. Okay, we need to do some propping and using a proper cut and try to determine how much rebar inside. So it's a common step what we did for conventional, lah. So the rectification process is the same, but yeah, we can alter the building, the slab floor anyway, but we need our consent also, lah. No problem.
okay. Can bubble deck be used for basement?
Currently, no, okay, because there's some uplift issue, lah. Okay, for basement, because we deal more on the uplift issue from the water, from the water downwards from the ground, right?
Okay.
So basically, we need a proper structure there, lah. Okay. So the proper structure, of course, the beam and slab, lah. There's more frame issue and more tight issue on that, lah. So,
Understand. Now, does it mean that the bubble deck system is much costly than the usual ones we use? Or do we do not have
okay. It depends on what type of system that we compare. Okay. As conventional, yes, we might be on the higher side, lah. Okay. But as compared to other system like flat slab itself, okay, there's a flat slab, conventional flat slab, okay. As compared to flat slab itself, yes, we can achieve maybe 10 to 20% lesser, okay, in terms of cost. As compared to PT slab, okay, PT slab also they are more cheaper, more convenient. And there's another type of precast also, like hollow core beam and slab. It depends on what type of system we compare, lah. Okay. But most of the case, we are slightly cheaper, around 5 to 10%. Okay. Overall, in terms of overall costing, lah. Okay.
5 to 10%. But if you could look at that, it's a time savings. And
Yeah.
there are a lot more other factors.
That's why I would say that you need to compare it in terms of overall comparison.
Whole process, the whole picture.
The whole process, your time framing, your reduction of your other materials such as scaffoldings, formworks and everything, and rubbish disposal, cut off your concrete usage on site. So you need to consider all of that. Then there's more increase on that as well, and more reduction on that as well.
Okay, one of the is that without beam, how
Is
to
there additional detail like stiffness to secure brick walls are not suitable for brittle walls? Correct me if I'm wrong. Okay, for flat slab, basically, okay, for our slab lah, actually, we can design the brick walls is in any position on top of our slabs. Okay, let's say during the design we have prefixed, okay, our brick wall locations and everything. But then suddenly the consultant asks, okay, can we change it into another directions? Yes, we can do that, because the application of the brick wall we can apply throughout the floor, because the ratio of the brick wall position we have emerged together into our slab design. So basically, there's no limitation, no such thing of additional stiffness in the bottom side of the brick wall position. So we can put in all locations into our slab. So no problem, even though it's without beams. Okay. I would say that.
But the stiffener between the brick walls sometimes is needed just to hold the brick walls, lah. But it's not really to support it. It's more of like to hold the verticalities of.
Yeah. But basically, our slab right now, we design it any position that you can do.
Because flat slab system itself is the structural system, you know, you can play.
We can play around the structure system, no problem.
And Andy come with
Okay.
the questions. Okay, bubble plastic resist heat. If it is used in a roof, will it crack later? I think this is sort of explained just now, too, but you could
Yeah,
re-explain again.
I can repeat the answer again. Yeah, yeah. Actually, the plastic balls either is burn out or just to resist it. It's actually the ball itself is just to create a void lah. Okay,
Mm.
the ball itself is not functional to resist any loads, to resist any heats or burns. So if you burn lah. Okay, not a problem for us. But only that how much the burning process it depends on. But I think up until now we have done a few testing requirement from the cream also with 2 hours fire testing and everything. Our slab still intact. So the structure integrity is still there. So I would say that the wall functional is only for the void ni lah, creation lah, just to reduce the slab weight itself. Okay. So no crack later. Yeah, there's no what to say
Problems.
problems lah.
Even if crack, it doesn't matter.
No, it
Yeah.
doesn't matter. Yeah. Okay.
Okay. Do you have
Okay,
any
thank you.
project done in Johor? Do you have any project done in Johor?
In Johor, we have one schools. Okay, one schools in Kota Tinggi.
Oh, okay. It's a private school.
No. It's a jenis kebahasaan Tamil. It's actually gabung school actually.
Okay.
SJKT Tamil in Kota Tinggi. I think just recently completed lah. Okay.
Okay.
But most of our project is here in Klang Valley lah.
Okay. I thought if it is at Johor, we could, get the student to visit it just to.
In Johor, we have apa lagi project selain daripada Kota Tinggi? We have one Sialin, one factory in Labis. In Sialin, Johor. In Muar, Johor.
Okay.
There's one factory. And another factory is a chicken eggs factory. Yeah, Tioseng factory lah actually. That one is in Batu Pahat.
Okay.
Yeah. We have 3 right now. Sorry.
3. Okay. That's good to know. Which means that client developer at Johor started to know more about the bubble tax.
We try to get more from Johor lah.
Yeah. But currently you do not have any branch of it here, right?
We have branch for our production team. Production area lah. In
But the
Johor, we have
design-
one in Labis.
But the design actually done in KL.
Yes. Design and manufacturing, most of them will be done here lah.
Yeah, we also started to see our student getting more and more exposed to bubble decks. If you could see our few years back, the final project, a lot of students keep saying bubble deck.
Yeah. Actually, we have some interested parties working with us together lah. We have 1 or 2 local youths actually, local universities, one in Pahang and one in here in Sedang here. They did a lot of bubble decks project also lah.
Okay.
So in UTM recently, we have one inquiry from the civil engineering faculties. So
It's regarding. What is it?
it's regarding for the performance of the bubble decks lah. Okay. I would say that more on the structural integrity, structural performance on this bubble decks slab. So we done quite a few detailed study also for the master students and PhD students. We working together with them lah.
Yeah.
Mm.
Yeah, I do understand that, like what you have mentioned, because all this while we are using the conventional and we get so used to E-beam. So I would say that even lecturers, sometimes we need to improve ourselves. If not, the student will get very, very, frustrated.
Because our mindset always say, wow, there's no beam. How can you restore it by themselves? That's the deal.
But
actually, it's one of the system.
But all this while we do have building without beam. I think some.
Yes. We've done it a lot.
I mean, even without before bubble decks, we have water slab. Everything is actually without, beam, but it's using the form to support it. But
Correct.
Yeah. Okay. I will just ask around if there is the question that the student might have a bit of other questions.
Maybe you can ask me more. No problem.
Yeah.
We have time.
But it is good. It is a good exposure for the students to understand the new technologies.
Yeah.
But just a chit chat, a casual chat. Normally, most of your project will it be like after the project face some issues, only they may come look for bubble decks as a solution, or they plan for bubble deck in the back?
At the beginning, yes. Okay,
Mhm.
once we started off in 2012,
Mhm.
most of our clients is turnkey project. Okay,
Ah,
I would
okay.
say they're trying to save. There's
Time,
another time trying to
labor.
save laborers and everything. So we came in later on. Okay,
Okay.
but throughout the years, when the product is in the market, I think more than 5 years, then we got some more requests from the consultant, from the architects to use into their buildings at the early stage. Meaning that we started off with design, prelim design as well.
Yeah,
Okay.
yeah.
Once the prelim design, and then we go for tender, we go for the awarding process to the contractors, and then we work together early with the contractors. So it actually started to we did this kind of activities since 3 years back now. Okay, I would